Okay, let's do converting between degrees and radians. But before, I want to write down very important relationship between degrees and radians. So, first of all, 180 degrees is pi radian. Okay, from here, if we want to know how many radians will be 1 degree, I'm going to divide by 180 degrees, right? And result, it's going to be 1 degree is equal pi over 180 radians. Okay. So from here, this is 1 degree. So, which means for the alpha degree, any alpha degree, we're going to have alpha times pi divided by 180 radians. Which means you are taking alpha and multiply by pi over 100. Okay, this is the very important formula for conversion. Okay, so let's practice this and then I'll do radians to degree. So 65 degrees is equal, as we said, we take the angle 65 and then time our pi over 180. Yes? So this is equal 65 times pi divided 180. Whoever needs to refresh the memory about multiplication of fraction, you can go to my channel and watch their multiplication of fractions. So 65 times pi over 180. So 65 and 180 we can divide by 5, right? Here we get 13. Here we get 36. So result we get how much? 13 pi over 36. So next one. Another one, 130 degrees. Same way, 130 times pi over 180. This is equal 130 times pi and dividing by 180. So first of all, this 0 I can cancel with this 0 with no problem. And then 13 and 18 I can't reduce by anything, so the answer will be 13 pi over 18. Next one, 90 degrees. 90 degrees times pi over 180 degrees. And that is equal 90 times pi divided by 180. So 90 and 180 can cancel, 1 and 2. And the answer will be pi over 2. Let me bring a little bit down, getting too crowded. Okay. One more. 630 degrees is equal 630 times pi over 180. That is equal 630. Oops. Times pi over 180. Okay. What we are going to get, so we can divide by, first of all, these zeros I can cancel with no problem. And then 63 and 18, both of them I can divide by 9. Yes, here I get 7. 18 divided by 9 is 2. And the answer is 7 pi over 2. All right, now let's solve a couple of problems how to convert radians to degrees. So again, let me show relationship. Pi radians are equal 180 degrees. So if I want to find 1 radian, then I'm going to divide by pi, right? So from here, 1 radian is going to be equal 180 over pi degrees. Okay, so, and if I need to calculate for, instead of 1 radian, for more radians, let's say, for example, theta radian, that's going to be theta times 180 over pi. Okay, might as well provide the whole line. Okay, and we have degrees. Pay attention what is interesting here. Let me compare to what I have here. So if I want to convert from degree to radian, okay, let me write down. If I want to convert from degree to radian, I need to multiply this degree by pi over 180. But if I want to convert from radian to degrees, I'm taking that the radian and multiply 180 over pi. So you flip it practically, pi over 180, and here you have 180 over pi. Okay? So in a minute, once I solve a couple of problems, I'll tell you how to remember not to get confused in what case 180 over pi and in which case it's going to be pi over 180. All right. Let's do it. So 8 pi over 9 is equal 8 pi over 9 times 180 over pi. So we're canceling this pi, right? 9 and 180, it's going to be 20. So the result is 160 degrees. Second one, let's say negative pi over 3. So negative pi over 3 multiply 180 over pi. We are getting here 3 and 180. You can 180 divide by 3. I'm getting here 60. That will be negative 60 degrees. Okay. Next one. Excuse me. Number 3. 6 pi over 5 is equal 6 pi over 5 times 180 over pi. Pi is gone. 5 and 180 I can reduce by 5. I'll get here 1. Here will be 36. And the result will be 36 times 6. 6 times 6 is 36. 3 in mind. 3 times 6 is 18. And 3, 21. So we get 216 degrees. And the one more. 2 pi over 15. 2 pi over 15 times 180 over pi. Okay, so pi and pi is gone. 15 and 180. So I can divide by 15, both of them, right? This is gone. This will be 12. And the result is going to be 24 degrees. Now, it's time to tell you how to remember in what case we multiply 180 over pi, in what case we multiply pi over 180. All right, so when you convert radians to degree, you want the pi is gone, degree stays. Therefore, you make sure, see everywhere, has to be pi, has to be at the bottom, so you can cancel with the pi that is on the top. Okay, see that? So let me that's weird, it's not shading. Okay, see, pi is disappearing. That's why we have every time we convert radians to degrees, my pi is always in numerator. Therefore, I have to make sure I have divide by pi too, because I won't get rid of pi, so degree will stay. And that's how you will know that you have to take 100 over pi. Okay? Now, and when you convert degree over pi degree to radians, then you want the degree gone, right? You want pi stay. That's why you always divide by degree, see? It's always in the denominator, so you can reduce, and pi stays in numerator. Pi has to be in numerator, so it will come out. Okay? Let me shade it. See, pi has to be in numerator. There we go. So it will stay. Because I want pi stay there. And degree has to be gone. Therefore, I'll just place it at the bottom, so it will, I can reduce or cancel and so on operations. Okay? All right. Let me move it down so to have it separated a little bit to different cases of problems. And I am done. All right. Okay, I have to put this on a new page. By the way, I am starting the channel of statistics. So whoever is interested in statistics, you can go to my channel and find statistics videos. Okie dokie. See you next time.